Okay, we're going to continue on with more practice problems from section 215. These arithmetic sequences. Remember, arithmetic are linear. Y equals mx plus b. So 7 years ago, Cody found a box of old baseball cards in the garage. Since then, he added a consistent number of cards. When you see added consistent number, think arithmetic. Think slope. Now, he had 52 cards in the collection after 3 years, and now has one. So he had 52 cards in the collection after 3 years, and now has 108 cards. So what we want to think is the number of years is our value for x. 3, and 52 is the number of cards, y. So x equals the number of years after start, and y is the number of cards. You want to get in the habit of identifying your variables. So then 7 years ago is when he started. So year 7, since he has 108 cards now, is 108. We want to write a rule. So we need to find the slope and we need to find the y-intercept. So the slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So it's going to be 108 minus 52, 7 minus 3. So it's going to be 56 divided by 4, which is 14. So we need to find out. So he's adding 14 cards per year, and we need to find out the starting point, the y-intercept. So use that y equals mx plus b. Pick a point. I'm going to do 352. So 52 equals 14 times 3 plus b. 52 equals 42 plus b, subtract 42 from both sides, b equals 10. So we have our equation, t of n equals 14, our slope, times n plus 10. That's the sequence. That's the rule for collecting the baseball cards. Now, how many cards were in the original box? That's our y-intercept. Start off with 10. Now, if he continues collecting, how many cards will be in the collection 10 years from now? Now, 10 years from now isn't year 10. That's year 17. Because we're in year 7, so 10 years from now, 7 plus 10 is 17. So t of 17 equals 14 times 17 plus 10. T of 17 equals, when you multiply, you get 248. So we'll have 248 cards. Okay, the next problem. Radio station is having a contest. If the caller answers correctly, incorrectly, $20 is added to the prize money, and the next caller is eligible to win. The current question is difficult. No one has won for 2 days. So 14 people have already called in when you called with the right answer, so you won $735. How much was the prize worth at the beginning of the day? So we need to write a sequence. So 14 callers, we're at $735. That's a point. Now, the $20, that's our slope, because that's how much is added for each wrong answer. So think we're adding 20, so it's linear. It's arithmetic, mx plus b. 735 equals 20 times x. X is 14. Plus b, because we're trying to find out what the starting amount was. So 735 equals 280 plus b. Subtract 280 from both sides. b equals 455. So beginning of the day, the prize was worth $455. So our model, we can actually model that. T of n equals 20n plus 455. I don't like that model. I'm going to take that back, pretend that didn't happen. So now, suppose the contest always starts with $100. Now we're going to make a model. If the person, I lied, we're not making a model. Suppose the contest always starts with $100. How many people would you have to guess incorrectly for the winner to get $1,360? So B is 100 and M is 20. We're still adding 20 for each wrong answer. Now we're just solving for x. So y equals 20x plus 100. So 1,360 equals 20x plus 100 because the prize was worth $1,360. Subtract 100 from both sides. 1260 equals 20x. Divide both sides by 20. X equals 63. You would need 63 people to get that prize up to $1,363 people to get that up to $1,360 in the prize bin. Let's do a few more on the next page. Here she's making, again, another arithmetic sequence. So is it possible that this sequence has a slope of 22? So they're telling us that t of 8 equals 164. So that's 8, 164. Then the 13th term has a value of 300. So that's t of 13 equals 300. So that point would be written as 13,300. What we're doing is we're checking to see, would the slope equal 22? Excuse me. So we look at the slope. M equals y2 minus y1, x2 minus x1. 300 minus 164 over 13 minus 8. So you're going to get 136 over 5, which is 27.2. Now that's not 22. So no, it didn't work. We needed to get 22. Our common difference, our slope was not the same that we wanted it to be. Two more. We're going to find the rule of the following arithmetic sequences. Now you can see we're not going up by one each time, and I don't feel like going in and filling out. It's actually not even written in order. Now these arithmetic sequences are linear. What we can do is we can find the slope and the y-intercept algebraically. We can pick any 2 points. So what I'm going to do is I'm going to pick the first 2 points. It doesn't matter which 2 points you work with. So that would be 7 and 54 in a more familiar form, 3 and 10. So for our slope, y sub 2 minus y sub 1, x sub 2 minus x sub 1. So we could do 54 minus 10 over 7 minus 3. So it's going to be 44 over 4. So the slope is 11. We need to find that y-intercept now. Y equals mx plus b. I'm going to use the second point, the 310. Doesn't matter which point you use. You could use any of the points on this graph. So 10 equals 11 times 3 plus b. 10 equals 33 plus b. Subtract 33 from both sides. So b equals negative 23. So our sequence, t of n equals 11n minus 33. So our starting point, term 0, is negative, that's 23, excuse me. Our starting point was negative 23. And our common difference, our slope, we're adding 11 each time. Last one. All we're given is 2 points. We're going to find the slope. Remember, our points are 110 and 2,100. So it's going to be 100 minus 10 over 20 minus 100. So it's going to be 90 over 70. Oh, excuse me, 90 over 80. Oh, it's a negative 80. So that's going to reduce to negative 9 over 8. So our slope is a fraction. That's okay. And we could pick either one of those 2 points. I'm going to pick the bottom one just because I feel like it. Y equals mx plus b. So y, 100, equals negative 9/8 times 20 plus b. 100 equals. Now we can reduce before we multiply. The 8 becomes a 2 because it's divisible by 4, and the 20 becomes a 5. So it's negative 45 halves plus b. I'm going to add 45 halves to both sides. b equals 100 plus 45 halves. I can change 100 to a fraction by multiplying by putting it over 1. We need to get that common denominator of 2, so we're going to multiply by 2 over 2. So b is 200 halves plus 45 halves. So b is going to be 245 over 2. Now we can't reduce that fraction, so the sequence t of n equals negative 9/8 n plus 245 halves. That's the arithmetic sequence. Okay, keep in mind, arithmetic sequences are linear. They're in that form of y equals mx plus b. We use that notation t of n for a sequence, and our sequences are discrete. When we see a sequence, we treat it as discrete.